Hello everybody. In this video, I want to introduce to you guys the concept of the mole. And what the mole is the mole is a unit just like a pair or a dozen. So one pair is 2 things, 1 dozen is 12 things, and 1 mole is 6.022 times 10 to the 23rd things. This is a really big number known as Avogadro's number, after the scientist Avogadro. So the first thing you're going to ask is, okay, but why do we care? And it just so happens that when we have a mole of a compound, it will have a mass in grams that is equal to the formula mass of that compound. And I'm going to give you some examples of how that works out. And I'm also just trusting that you guys are just going to take my word for this. The story of why this is true all starts with a guy named Avogadro and some really cool experiments that he did with gases. And we might be able to talk about that a little bit in the final weeks. But for right now, we need to know that the consequence of this is that 1 AMU is equal to 1 gram per mole. These are now equivalent units. All right. So formula mass or molar mass is the amount of mass per mole of a compound. And the way we're going to calculate this is we're going to do it just like we were calculating how many AMUs there were in a compound from the atomic masses. But I want to do a little review for us. So first we're going to start by determining the number of each type of atom. We're going to distribute any subscripts of parenthetical terms. So anytime we have parentheses and stuff, we have to do some math around that. We're going to add all of the subscripts for each type of atom together. And then we're going to remember that any omitted subscripts are 1s. Then we're going to multiply each atomic mass by the number of atoms of that type. So let's do an example here. If we have magnesium nitrate, remember this is a polyatomic, and we're saying there's 2 of these NO3s on every 1 magnesium. The first thing we need to do is distribute through this parenthetical term. So when we do that, we get magnesium. We have a 1 right here. We're going to do 2 times 1 so that there's 2 nitrogens. And then we're going to do 2 times 3 to show that there's 6 oxygens. Then we're going to go to our periodic table. We're going to see that magnesium has an atomic mass of 24.305 AMU. We have 1 of them. We do 1 times that, and we have 24.305 AMU for magnesium. To do, then we're going to look at the nitrogen. So we have 2 nitrogens. Its mass is 14.07 AMU. So the total contribution from nitrogen is 28.0414 AMU. And then there's 6 oxygens. We'll multiply it by its atomic mass. And we'll see that there's 95.994 AMU from the oxygen. We'll add all of these values together. And we'll see that the entire formula mass for magnesium nitrate is 148.313 AMU. Let's look at this other example. So here we have what is the mass of 1 mole of ammonium chloride. And then I've drawn out here the formula for ammonium chloride. So we have ammonium, one of our polyatomics, NH4, it has a positive charge on it. And then we have our chlorine atom here. It's going to have a -1 charge on it. This is like a ionic type compound. If we first look at the nitrogen, we have 1 nitrogen times its atomic mass, 4 hydrogens times its atomic mass, and 1 chlorine times its atomic mass. We multiply these all through, and then we add down. We get 53.489 AMU for ammonium chloride. And now we use the fact that AMU is an equivalent unit to grams per mole, and we can see that there are 53.49 grams for every mole of ammonium chloride. And then if we wanted to actually see the units play out here, we would take that 53.49 grams per mole, we'd multiply it by the 1 mole, because the question asked us what is the mass of 1 mole, and we get 53.49 grams, and we have units of mass. So let's look at another example of the type of question you could be asked about moles. What is the mass of 0.23 moles of potassium oxide? So first thing we need to figure out is how much 1 mole of potassium oxide weighs, and what is the formula for potassium oxide. So we know oxygen has a -2 charge, potassium tends to have a +1 charge, so we're going to look at K2O as our formula for potassium oxide to balance the charges on the two. We know that an atom of potassium weighs 39.098 AMU. We have 2 of those. We know an atom of oxygen weighs 15.999 AMU. We'll add those two together and we'll see that a molecule of potassium oxide weighs 94.195 AMU. We know that AMU is the same unit as grams per mole. And we can see here that when we multiply by moles, the 0.23 moles from the problem, we will cancel the mole unit and we'll be left with 22 grams of potassium oxide. If you can't tell already, there are many different ways that you're going to be asked questions about moles. And I'm going to show you 2 more problems now. This one here says how many moles is in 3.52 grams of hydrogen gas. So hydrogen gas is one of our diatomics. We learned about that when we were writing Lewis structures. To figure out the mass of this, we can see that we have 2 hydrogen atoms. Each hydrogen atom weighs 1.008 grams per mole. We multiply that by 2. We can see that each one of our hydrogen gas molecules weighs 2.016 grams per mole H2. If we have 3.52 grams of it, we will set up our ratio here. 1 mole of H2 gas for every 2.016 grams. Cancel our grams, and we can see that we have 1.75 moles of H2. You may also notice that I sometimes just write MOL instead of MOLE, but that is a pretty accepted abbreviation. So you'll often see something like MOL written out in chemistry, and you shouldn't let that sway you. Next, we're going to ask the question, how many atoms are in 1.857 moles of carbon? And this one is a little misleading because it actually doesn't matter that it's carbon at all, because the only fact that we need to know here is that there's 6.022 times 10 to the 23rd atoms in 1 mole of any element. So we just take the number of moles here. Again, we're going to cancel that unit. multiply it out, and we get this really big number here, 1.118 times 10 to the 24 atoms of carbon. Now, if we had been given this problem where we had mass, we would have had to use the actual fact that we had carbon to determine the number of moles of carbon that we had. So let's take a look at an example where we're going to do just that. In this question, we're asking how many atoms are there in 100.00 grams of nickel. So in these types of problems, we're going to have to go from mass to moles and then to atoms. And we can do this all in one expression. So first we start off with our mass, 100.00 grams. We then want to know how many moles there are. And we know that for nickel, it has an atomic mass of 58.693. So for every 1 mole of nickel, there are 58.693 grams. And then we need to go over to the number of atoms. We've canceled our units of mass here, grams and grams. So we need to go from moles to atoms. And we know that there's 6.022 times 10 to the 23rd atoms for every 1 mole. We'll cancel that. And that leads us to the conclusion when we do this division and this multiplication, that there are 1.026 times 10 to the 24th atoms in 100 grams of nickel.